All right, so we're going to begin and dive right on into Chapter 1, Section 1.1, and we're going to talk about the basic ideas of statistics and what the whole point of statistics is, and what are studies, and how do we sample, and how do we collect data, and then how do we analyze, how do we even begin to analyze that data. So before we can talk about any of that, we need to know some basic vocabulary. And the first thing we want to know is, what in the world is statistics in the first place? Well, statistics is just the study of procedures for collecting, describing, and drawing conclusions from information. So basically, we gather a bunch of information and we want to figure out, all right, what is this information telling me? What good is this doing? How is this helping me to figure out something else, or to make conclusions based on some theory or based on whatever it is at hand? When we're talking about statistics, we have to be focused on particular groups of people. And one popular word that we'll use a lot throughout this entire course is the population. The population refers to the big picture. That's how I like to call it. The big picture. Everybody, the entire collection of individuals about which information is sought. So you're looking at this whole big group of people that share this common characteristic. But unfortunately, in statistics and in research studies, it's very uncommon for you to be able to perform some type of study based off of that population. So instead, from that population, you take a smaller proportion of that group. So you take a proportion of that big picture, and we call that our sample. And our sample is just some subset of the population. And then we conduct our study on that sample, and then we make conclusions from that sample to our population. Now, two other popular terms that we need to know, or two that we need to understand, are what is a statistic versus what is a parameter. Now, when I refer to a statistic, I'm talking about a number that describes a sample, whereas a parameter is a number that describes a population. So let's look at how we tell the difference. If you look at this example here, 57% of the teachers at Jack Britt High School are female. And then in the second sentence, I have, in a sample of 300 people given a new pain reliever, 30% reported an insignificant amount of relief. Now, I want you to take a minute and identify which one you believe is the statistic and which one you believe is the parameter. Now, if you look at the first sentence, 57% of the teachers at a whole high school are female. We're talking about an entire group of people, an entire population. So what do you think that's going to be? It's obviously going to represent a parameter. Whereas the second sentence is talking about a sample, and the 30% that reported an insignificant amount of relief deals with individuals within the sample. And so that number represents a statistic. Now, when we're completing samples, there's many different types. The very first one is a simple random sample, and I'll refer to this as an SRS throughout this course. The formal definition of the SRS, it has size n being any number, chosen by a method in which each collection of n population items is equally likely to make up the sample. And so a simple random sample is actually the best type of sampling method because it's the most fair. Everyone, everything, whatever the thing is that you're dealing with has an equally likely chance of being part of the sample. So there's no one thing that is more likely to be picked than another. And so it makes everything fair, everything equal, and it's just the best type of sample that you can conduct. So let's say that there are 323 people who register for a drawing of a Target gift card. 20 people are going to be selected to win this gift card. Target wants to ensure that everybody has a fair chance of winning a gift card. So a number list of all 323 people is made, and a random number generator on a computer then generates 20 numbers between 1 and 323. The people who correspond to these numbers make up the sample. So every single individual was given a number, but no number was more likely to be chosen than another. This is very similar to a lottery. So this is definitely an example of a simple random sample, and it was definitely fair. Nobody else had more of a chance to be selected than somebody else. Now here's a bad example. Ms. K wants to study the math ability of students at her university. She plans to draw a sample of 50 students to fill out a questionnaire about which athletic activities they participate in. This case, 8 a.m. stats class has 50 students, so she uses the first 15 minutes of class to have the students fill out the questionnaire. This is a really bad sample set because, first off, it's definitely not random. I selected the people that are all in my stats class. Well, statistics is definitely a higher level of math, so it would be fair to say that individuals in my stats class are more likely to be stronger in their math ability than maybe students that are in a lower level math course. Therefore, this isn't really a simple random sample, and not everybody has an equal likely chance of being selected, nor do they have an equally likely chance of representing the true essence of my population. So this is just a really, really poor example. Samples of convenience. Now, when I talk about a sample of convenience, it is a sample that is not drawn by a well-defined random method. Now, you want to avoid samples of convenience whenever possible. Yes, just like it sounds, it's convenient. It's probably the easiest way to go about things, and it's going to make your life a lot easier. But it's going to produce results that just are not accurate. It will not represent your population well. So let's say that I want to survey 100 students on their attitudes towards the eatery options available on campus. And so I pull the first 100 students entering the Chick-fil-A spot on campus. Well, if you think about that, this is extremely convenient. I'm standing in front of a Chick-fil-A spot on campus to survey people about how do they like the eatery on campus. Well, don't you think that the people eating at Chick-fil-A on campus obviously like it? So that's probably not going to represent the attitudes of the entire campus very well. It's definitely going to be biased. But that was definitely convenient on my part because I didn't really have to do anything. I just stood and picked the first 100 people that I saw. So you definitely want to try to avoid this whenever possible. It's just not going to generate a substantial amount of strong data. Some other sampling methods are the stratified random sample, a cluster sample, systematic samples, and then voluntary response samples. Now, I actually want you to read in your textbook more about these to gain a better idea, but I want to give you a brief overview. When you talk about a stratified random sample, just breaks your population into strata. And so the strata are going to be groups that seem natural. So let's say that we're talking about a company, and this company has 100 employees, okay? And let's say that some of them are full-time and some of them are part-time, and I want to poll these 100 employees about their opinions regarding the benefits. Well, it probably wouldn't be fair to just look at the 100 as a whole and then select a certain number out of that 100 when some of them are receiving more benefits than others just because some are registered as full-time employees whereas others are part-time. So I would break these up into strata. One strata being my full-time employees and the other strata being part-time employees, and then conduct a simple random sample from each strata. That will give me better results. If I'm talking about a cluster sample, I'm basically it's whenever my population is too large or it's too spread out. And so simple random samples just aren't feasible. So I'm going to break my entire population up into different clusters, and then when I select my clusters, I will look at everybody within that specific cluster. Systematic sampling is looking at every case. That sounds a little weird saying it out loud without showing it to you, but looking at every other person. So maybe I say, hey, you know what? I'm going to look at every 10th person, and that is the individual that will be part of my sample. And then there's voluntary response samples, which we'll talk about later on in the chapter. But basically, these are really weak methods. If you think about American Idol, that's a type of voluntary response sample. You know, hey, if you want to vote for Sally Mae, call this number and dial 3221. Well, the individuals that are going to respond to that are extremely, extremely opinionated. They're going to be the individuals that truly support Sally Mae or whoever they're calling in to vote for. And so you notice that there's a strong bias whenever we talk about a voluntary response sample. All right, and so these actually, that concludes our chapter 1, section 1, sampling methods. Again, we will talk more about these in class, but I hope that gave you a pretty good overview of this section.